Okay, here we go. So taking a look at example 2. So this is the last page of your note packet. Our directions say write a recursive rule. Write a recursive rule for each sequence. Okay. Now, basically, you guys, our job is to figure out, what's that common difference or that ratio. And then we've got to come up with our equation based off of that. So if we take a look at our first example, letter A, we got to figure out, okay, how am I getting from negative 30 to negative 18? How am I getting from negative 18 to negative 6? Negative 6 to positive 6. Positive 6 to 18. So when I look at each of those, I start to realize that I'm just adding 12 to each of these. Okay? Now, since I'm adding, that turns into a difference. Okay? So that common difference that we're looking at is 12. Our formula that we're going to use then, since this right here is arithmetic, because we're adding, we're going to use that formula of a sub n equals a sub n minus 1 plus d. So that's that recursive equation for an arithmetic sequence. So if you remember back to the definition for a recursive rule, remember a recursive rule gives the beginning term, in this instance, just term singular, we don't need multiple. So actually our recursive rule needs to start off by saying that our first term, a sub 1, is negative 30. And then from there we go on to say the actual rule, a sub n equals a sub n minus 1. Okay, so again, kind of trying to find that previous term. And then that common difference is 12. So we would be able to find the second term, third term, fourth term. We'd be able to find subsequent terms now that we have both of these pieces. Because that a sub n minus 1, remember, we need to use the previous term in order to find the next one. So in order to find term 2, you need term 1. In order to find term 74, you need term 73. Okay, so you need to be able to define what that first term is in order to find the subsequent terms. Okay, then kind of going over to letter B, again, we got to figure out how am I getting from 500 to 100? How am I getting from 100 to 20, 20 to 4, 4 to 0.8? And I kind of look at that and I realize, well, you can't be adding or subtracting, because getting from 500 to 100, you'd be subtracting 400. And then 100 minus 400 is not 20. So it's got to be some sort of ratio. So I am going through and I'm kind of thinking, okay, how do I get from 500 to 100? I'm multiplying by 1/5 each time. And remember, you should always check just to make sure that that ratio is staying consistent throughout all of it. Okay, so again, we've decided that it's a ratio, that it's being multiplied, which means that it's geometric. So that ratio is 1/5. So since we've got a geometric, we're gonna all of a sudden use the formula a sub n equals, now we're gonna use r. So before we used d because we had a common difference, this time we're using r because we have a common ratio. R times a sub n minus 1. So for our recursive rule, remember, we need to define what our first term is. So a sub 1, just looking at the problem, the original problem, our first term is 500. And then our rule, so a sub n equals 1/5 times, and I'm just going to put this in parentheses so that we know we have to multiply, a sub n minus 1. And that's our recursive rule here. So now I encourage you guys to take a look at the next two. So here's my next two. Realistically, you guys, these are no different. They're just set up as tables instead of as a like basic sequence where you just have one term after another after another. So really no difference here. Take a second, see if you can come up with your recursive rule. I'm going to pause my video here and I'm going to show my work and hopefully we come up with the same thing. So take a pause and let's try this one. Okay, here's our work. So for the first one, you're multiplying by 1/3 from each of your terms. So that then forces you to use the a sub n equals r times a sub n minus 1. Make sure you define your first term. And then you come up with your recursive rule. And then same thing for the bottom one, except it's an arithmetic. So top one is geometric, bottom one is arithmetic because you're adding. And you should be good to go from there. Okay, this is going to be the end of our second video. The third video is probably going to be a little bit longer because I'm going to do 2 examples in one, and then I will do a separate one for the 5th example. So the next video will have examples 3 and 4, and then the final video will have example 5.